Let's solve the problem. Looking at question 11, it involves performing a thyroid ultrasound, and the question asks you to choose the option related to changing the acoustic power to -3 decibels. Here, -3 decibels can be interpreted as the original power value being reduced by half. If you choose the option related to this content, you can select option D. The fact that the power has been reduced by half also means that the intensity has been reduced by half. Power and intensity are directly proportional, and amplitude is proportional to the square of these values, so you can solve the problem by connecting these basic characteristics. Moving on, let's look at question 12. If you look at the main text, the process in which sound propagates, this expression refers to a vacuum. This question asks you to choose the correct option that explains what happens when sound propagates in a vacuum. In a vacuum, since there is no air, it is an environment where sound cannot propagate. The correct answer is to choose the option that says sound is not transmitted in a vacuum. Next, let's look at question 13. When you see a sentence that's this long, it's best to focus on the last sentence. Even if you don't know the earlier content, what the question is ultimately asking about is the range of audible sound. Among the choices, you should select the one that falls within the audible frequency range. Basically, you write down 20 and 20, then label one as hertz and the other as kilohertz. The range from here to here can be considered the audible sound range. Frequencies below 20 Hz are considered infrasound, and those above 20 kHz are regarded as ultrasound. If you choose the option among the choices that falls between 20 and 20 kHz, you would select option B. So, since this is the most basic item, you just need to remember the audible range, as well as the areas related to infrasound and ultrasound. Let's look at question 14 below. If you look at the sentence, it's asking about the maximum quantitative change in a cycle. I'll explain this while looking at the diagram. If you look at the diagram, this part corresponding to the maximum in the cycle is called the amplitude. You can think of it as the part related to the highest point. Additionally, as a reference, the length from the first peak to the second peak is called the wavelength. When a cycle appears like this, you just need to remember these two key concepts that come up most often. Once again, the change to the maximum is called the amplitude, and the distance between the first and second peaks is called the wavelength. Just keep these concepts in mind. Since what the question is asking about is related to the maximum change, the correct answer would be to choose the amplitude shown in option A. Let's move on and look at question 15 next. In the case of this problem, you can see it as a question that asks about a more fundamental and deeper concept in physics. Bulk modulus can be interpreted in Korean as chejok tansungnul, which means volumetric elasticity. The option related to these aspects would be option B. Since this is a rather deep topic in physics, you don't need to focus too much on the finer details. Just keep in mind that this term refers to volumetric elasticity, and that the related item is associated with stiffness or hardness. Yes, what I want to emphasize is that among the overall concepts in physics, the physics related to ultrasound is typically covered on the exam. However, there are cases where questions related to all areas of physics appear in this problem book. You don't need to study these topics too deeply. I can tell you that just having a general understanding of the connections is enough and won't cause any major issues. Moving on, let's look at question 16. If you look at the sentence, this is a question where you have to choose the correct statement about the characteristics of sound propagation in a medium. Let me first explain this while looking at a related diagram. For sound to be transmitted, it uses a medium called air. You can think of it as being transmitted by causing vibrations in the particles of air. So, you can think of sound as being transmitted by the repetition of compressed regions, called compression, and rarefied regions, called rarefaction. The most crucial point to understand is that it's not the physical medium itself that moves from place to place, but rather the process is transmitted as the air vibrates back and forth in a continuous wave. So this is a process of vibration of particles, and it is not related to the idea of any material itself moving to the other side. Let me explain this again while looking at the main text. If we check the answer first, it would be option B. Yes, you can think of it as the molecules vibrating and thus causing the movement. These are the most basic ways to describe how sound waves are transmitted. Next, if you look at the sentence, the parts about movement are not related to the idea that the medium itself moves from one place to another, so you can see that the movement of the medium does not occur. To summarize once again, the most important characteristic of sound propagation is the vibration of molecules. I want to emphasize again that sound is transmitted through the process of compression and rarefaction, and it is not related to the idea that a particular medium itself moves to another place. Let's move on and look at the next question. This question is asking about a basic concept. It asks for the term that refers to the time it takes for one cycle to occur. The correct answer is period, which is option D. Please remember this sentence as well. Let's move on and look at the next question. If you look at the sentence, you'll see the terms number of cycles and pulse, and it mentions that the pulse has increased. As a result, up to this point, the expressions here refer to frequency, but the fact that the pulse has increased can be seen as a clue indicating pulse repetition frequency. If you look at the evidence for that, it explains that the wavelength remains the same. If the frequency had increased, the wavelength would normally decrease because they are inversely proportional, but despite the changes mentioned here, it is explained that the wavelength does not change. This suggests that the part mentioned earlier refers to the pulse repetition frequency, which is different from the actual frequency. Now the question is to choose the correct answer based on this situation. To sum up, this problem is about selecting the answer related to a situation where the PRF increases. Yes, when the PRF increases, the related answer is C, which states that the pulse duration increases. Since the pulses are repeated more frequently, the pulse duration, which is the time the pulse lasts, can also increase, so you should consider C as the correct answer. Let's move on to the next question. Looking at question 19, it asks what adjustments are needed to decrease beam intensity. If you look at the intensity formula, you can see that area is on the bottom and power is on the top, which is the formula for intensity. So if you want to decrease the intensity, you can increase the denominator at the bottom, which will reduce this value. Therefore, if you increase the area, you should choose option D, where the intensity decreases. In the case of option A, this actually means the power increases, so the intensity would increase instead. Reducing the receiver gain is completely unrelated to the core of the question. Furthermore, regarding options C and E as well, making those specific types of adjustments would actually result in the overall intensity increasing rather than decreasing. Because of this, we can safely rule them out. Now, let's move on and take a detailed look at the next topic in our lesson. Since this is a basic question, let's find the answer right away. In human tissue, ultrasound waves have the characteristic of being mechanical longitudinal waves. So the correct answer is option A. This can be described as a question asking about the most fundamental property of ultrasound.